Welcome all. We are with motion in straight line, that is one-dimensional motion. Problem number 2. We'll try to solve it. Let us see. An apple is dropped from the top of a building 75 meter tall. At the same time, a mango is thrown upwards from the foot of the building with a velocity of 30 meters per second. When and where apple and mango meet? So what is given? Let us analyze it with a picture. Let us consider this is that building, and it is given that the height of the building is 75 meter, as it is given 75 meter tall building. See here. Yes. And from the top of the building, an apple is falling down. At the same time, a mango is thrown upwards, and they will meet at a point. Just imagine this is a meeting point. And when they meet, the apple traveled a distance h meter. I will assume so. And that is why the height reached by the mango will be 75 minus h, because total height of the building is 75 meters. Okay, so let us write this, what we have considered. Let h, we have taken h meter be the distance traveled by the apple when mango reaches 75 minus h meters height. Okay, this is what we have assumed. Next, we will consider the motion of apple. So we will consider for motion of apple. Okay, only consider the motion of apple now. Suppose if I consider initial velocity of the apple, let me consider it as V0. Initially, before it is falling down from the top of the tower, top of the building, it is 0. Okay, so we will consider it as 0. And what about acceleration? As it is falling down, acceleration A will be equal to, it will be equal to G actually. According to the sign, it is minus G. So you know the value of acceleration due to gravity. It is minus 9.8 meter per second square. Okay. Then what is the displacement? Up to which the mango and apple meet. Up to that point, what is the distance or displacement? We are writing x equal to h, h meters. Okay, we have considered that. So as it is falling down, I will consider it as minus h. Okay, whatever we take in downward direction, we'll consider that as minus, and whatever we consider in upward direction, that will consider as positive, plus. Okay, so we will use one of the equations of motion, that is, we'll use it for the displacement. We have using equation. Which equation we'll use? We'll use the equation for displacement, x equal to v naught t plus half at square. We'll use it where v naught is the initial velocity, a is acceleration, and t is time. Okay, and we'll substitute the values whatever we know. X is minus h, that that is equal to, as v naught is 0, the first term becomes 0. Then a we have taken as minus g, so it will be minus of half into 9.8 into t square. Okay, so it will be minus h equal to 9.8 by 2, it becomes half of 9.8, that is 4.9. Okay, so it will be minus 4.9 t square. So we got one equation here. We will consider it as equation 1. Okay, this is for motion of apple. Now we will consider the motion of mango. So I'll write here for the motion of mango. Initial velocity, we will consider again initial velocity. We'll consider it as v naught again, v naught for mango. That is given in the question, it is given. You can refer back. 30 meter per second. Mango is thrown upwards from the bottom of the building with a velocity 30 meter per second. So v naught is 30 meter per second. And what about acceleration? Acceleration A. And that is as it is vertical motion, again it is minus g. G is acting downward, that is why minus always. So it is minus 9.8 meter per second square. Okay, then what about displacement? It is x, that is we already have in the diagram 75 minus h meters. This is the displacement. Okay, so again we will use the same equation. Using the same equation, x equal to v naught t plus half a t square. We'll substitute the values now. That is 75 minus h, that is x, that is equal to v naught is 30. So 30 t A is minus D, that is why minus half into 9.8 T square. Okay, yes. So it is again, if I write 75 minus H will be equal to 30T minus 4.9 T square. Okay, yes. And this is equation 2 I will consider. So now I am substituting equation 1 in equation 2. For 4.9 T square, I will substitute equation 1. You already got in equation 1 that minus 4.9 T square is minus H. So in place of 4.9 T square, I can substitute equation 1. So I'll write here substituting equation 1 in equation 2. What I'll get, I can write it as 75 minus H equal to 30T minus, that is H from equation 1, it is H. So I can cancel H here. So what is remaining? 75 equal to 30T. So from this I can get the value of T. What is T? T is time. So time at which they are meeting. So T equal to what it is, 75 divided by 30. So if I do the calculation, I will get it as 2.5 seconds. Okay, this is the time at which they are meeting. So I can write after 2.5 seconds they meet. Apple and mango will meet after 2.5 seconds. Now we need to calculate the other things. So we will substitute T, value of T. Substitute T in equation 1. Okay, so you know what is equation 1. H equal to minus 4 minus H I got. So minus H equal to minus 4.9 T square I got. So here I can write H equal to 4.9. In place of T I will substitute 2.5. 2.5 square. So if I do the calculation, it will be, I will get it as yes, 30.625 meters. So this is the distance traveled by the apple. Okay, and similarly I can calculate the distance traveled by the mango also. So for that, what I have to do, mangoes, the distance traveled by the mango is 75 minus H, isn't it? So that is equal to 75 minus 30.625. So if I calculate it, I will get it as 44.375. Okay, this is the distance traveled by the mango. You can imagine, you can understand. You can understand the picture, isn't it? From the picture you can understand. H is this and 75 minus H is this. So we got the answer here, final answer, that is 30.625 meters and 44.375 meters. Okay, thank you.